All right, so before I do the problem at hand, I'm going to make up an example with some sets with less elements. So let's say that set P included the numbers 1, 2, 3, and we have another set, I'll call it set Q, and it contains the numbers 2, 3, 4, and 5, I suppose. All right, so we have two sets. If we wanted P intersection Q, okay, so when this symbol right here, this upside down U looking thing, it's read as intersection. So this is, we would read this out loud as P intersection Q. This wants me to identify the elements where the two sets intersect at. It wants me to identify the elements that are in both P and Q. So when we see this upside down U looking thing, we can look at it as the word and. It represents the word and in mathematics. So we want to identify the elements that are in both P and Q, and that contains the numbers 2 and 3. On the other hand, here we have P union Q. So this U looking symbol, it's read as union. It's called a union symbol. And it represents OR in mathematics. P union Q, that means all the elements that are in P or Q. So they can be in either one. In order to identify P union Q, we could just copy all the elements that are in P, and then we would also include any additional elements that are in Q. You know, Q has 2 and 3, but I've already wrote them down, and so I would have 4 and 5. These are all the elements that are either in P or they're in Q. So again, intersection, the upside down U, that means we want to identify the elements that are in both sets. You know, that they're in it's and they're in both P and Q. And the union, they can be in either one. All right, so now I'm going to do the problem that we're doing up here. A union B. A and B look like, you know, they're rather bigger. They're big sets. They have more elements in them than the P and Q do. If we wanted to figure out A intersection B, that would be all the elements that are in A and B. They're in both. So what are the elements that are in both A and B? It looks like -2 is in both of them. I see that number 1 is in both of them. And it looks like 9 is in both of them. So those are the numbers that are in both of them. That's where the two sets intersect at. And that's, again, that intersection means and. Now, but the actual problem wants me to figure out A union B. A union B. So now these are all the elements that are in A or they're in B. So it can be in either one of them. This is going to be a bigger set, a much bigger set than A intersection B. Well, so you just list all the elements that are in A or B. So you don't have to put them in order, but I'll try to put them in increasing order, but it's not essential that you put them in any particular order. So -6 is in B, -3 is in B, -2 is in B, it's in A as well. And then we have 1, 3, and 4 are in A. I'm putting them in order, but it's not essential that we do. 6, 8, 9, and 15. It's basically all the different elements. You know, these are all the elements that are in either A or they're in B.